Muscle function is fundamentally dependent on ion movement across the muscle cell membrane, also known as the sarcolemma. These ions establish electrical gradients that enable muscle contraction and relaxation. Without proper ion regulation, muscles would not be able to generate force or respond to neural stimulation. Ions like sodium, potassium, calcium, and chloride play critical roles in muscle physiology. Their movement across the membrane determines the resting membrane potential, action potential propagation, and excitation-contraction coupling. Proper ion balance is essential for preventing disorders like muscle cramps, paralysis, and fatigue. Muscle cell membrane structure. The sarcolemma is a specialized cell membrane that encloses the muscle fiber. It consists of a phospholipid bilayer interspersed with proteins that facilitate ion transport. The hydrophobic nature of the lipid bilayer prevents free passage of ions, requiring specialized protein channels and pumps to regulate ion flow. Membrane proteins, such as ion channels, transporters, and receptors, control the movement of key ions, ensuring proper muscle function and response to neural stimuli. Key ions in muscle function include sodium, potassium, and calcium. Each of these ions plays a crucial role in muscle contraction and relaxation. Sodium, or Na+, is essential for generating action potentials. The rapid influx of sodium ions depolarizes the membrane during muscle activation. Potassium, or K+, maintains the resting membrane potential. The efflux of potassium ions repolarizes the muscle membrane after contraction. Calcium, or K2+, triggers muscle contraction by binding to troponin, enabling actin-myosin interaction. It is stored in the sarcoplasmic reticulum and released upon stimulation. Chloride, or Cl, stabilizes membrane potential and prevents excessive excitability. Magnesium, or Mg2+, regulates ATP-dependent ion pumps. It also helps in muscle relaxation and prevents excessive contraction. Ion channels and transport mechanisms play a crucial role in maintaining cellular function and homeostasis. Voltage-gated ion channels open and close in response to changes in membrane potential. For example, sodium channels initiate depolarization, while potassium channels aid in repolarization. Ligand-gated ion channels are activated by neurotransmitters like acetylcholine at the neuromuscular junction. Ion pumps, such as the sodium-potassium ATP PACE and calcium pumps, maintain resting membrane potential and muscle excitability. The sodium-potassium ATP PACE restores ion gradients after an action potential. Calcium pumps remove calcium after contraction, allowing for relaxation. Passive diffusion and leak channels allow continuous ion movement to stabilize resting potential. The role of ions in muscle excitation and contraction is crucial. The resting membrane potential is the electrical charge difference across the sarcolemma in a resting muscle. It's maintained at around -70 millivolts by the sodium-potassium ATP PACE pump. 5.2 Action potential generation and propagation, initiated by sodium influx leading to depolarization. Repolarization occurs due to potassium efflux. The process propagates along the muscle fiber to trigger contraction. 5.3 Calcium's role in muscle contraction, released from the sarcoplasmic reticulum when an action potential arrives, binds to troponin, shifting tropomyosin and exposing actin sites for myosin binding, leads to muscle contraction through cross-bridge cycling. 6. Neuromuscular junction and ion activity. Acetylcholine, or AC, binds to receptors, opening sodium channels to initiate muscle contraction. The age-induced sodium influx leads to depolarization and action potential propagation. Calcium influx in nerve terminals triggers neurotransmitter release. Disorders related to ion imbalance in muscles can significantly affect muscle function and overall health. Hypokalemia and hyperkalemia are conditions related to potassium levels. Low potassium or hypokalemia causes muscle weakness. On the other hand, high potassium or hyperkalemia leads to excessive excitability and even arrhythmias. Hypocalcemia and hypercalcemia refer to calcium level imbalances. Low calcium, known as hypocalcemia, results in spasms and cramps. Conversely, high calcium or hypercalcemia leads to muscle weakness and sluggish reflexes. Muscle cramps and fatigue due to ion imbalance occur because electrolyte imbalances disrupt normal muscle contraction and relaxation. Mutations in ion channels cause conditions like periodic paralysis and myotonia. Regulation of ion homeostasis in muscles. Hormonal control, including aldosterone and parathyroid hormone. Aldosterone regulates sodium and potassium balance. Parathyroid hormone controls calcium levels. Role of the kidney in ion balance. It filters and reabsorbs essential ions to maintain homeostasis. 8.3 Dietary and nutritional factors affecting muscle ion levels. Proper intake of electrolytes supports muscle function. 9 Ion-related drug effects on muscle function. 9.1 Muscle relaxants and ion channel modulation. Drugs like dantrolene block calcium release to reduce contractions. 9.2 Ion channel blockers and neuromuscular effects. Medications targeting sodium or potassium channels can affect excitability. 9.3 Medications for treating ion imbalance disorders. Electrolyte supplements help restore balance in muscle dysfunction. 10 Advanced research on muscle ion dynamics. Ion channelopathies and genetic research. Ongoing studies on inherited muscle ion disorders. Emerging therapies for ion regulation. New drugs and treatments targeting ion channels. Future directions in muscle ion studies. Exploring novel ways to modulate ion function for better muscle health. Well, we've reached the end of our journey. Thank you for joining us. Remember, the key to success is consistency and dedication. Stay curious, stay informed, and most importantly, stay healthy. Until next time, take care. Muscle function is dependent on ion movement across membranes. Imbalances can lead to severe muscular and neurological disorders. Understanding ion dynamics can improve treatments for muscle-related diseases. Advances in ion channel therapies hold promise for treating neuromuscular disorders. If you found this guide helpful, make sure to subscribe, like, comment, and share Liz J Naturals. Your support helps us create more educational content on muscle health, nutrition, and overall well-being. Drop a comment below with your thoughts and let us know what topics you'd like us to cover next.